Welcome to this week's video tutorial. In this week's tutorial, we are going to cover factor analysis. Factor analysis is used to reduce a large number of variables to a smaller set of underlying factors that summarizes the essential information contained in the variables. In this week's tutorial, we are going to use the dataset presented on the screen. In this dataset, there are 388 participants who responded to a survey regarding organ donation. They completed a 16-item Likert scale question that was designed to measure their attitude towards organ donation. The researcher wished to use factor analysis to determine the underlying factor structure of these variables and therefore decided to use factor analysis. So to conduct factor analysis, we are going to click on the Analyze menu and then Dimension Reduction and then Factor. So we will select all the variables and click the push button and then click on descriptives. Once you've clicked on descriptives, click on coefficients, click on KMO and Ballet's test of sphericity, click on anti-image and ensure that the initial solutions in the statistics box is checked. Then you click on continue and then you click on extraction and then you ensure that principal component is selected. Then you click on the tree, so it's checked. And then you click on continue. Then you click on rotation and probably use direct oblimin. You click on continue and then you click on options. Then you check sorted by size, suppressed by small coefficients, and then you put 0.3 as the absolute value. So click on continue, then you click on OK. So this is the output that appears. So like we've been saying before, we need to take this information to a convenient word processing software. So we go back, copy the relevant tables, So these are the important tables. So this first table is just a correlation matrix, basically showing the correlation between the variables. So we have this set of variables correlated amongst themselves like that. The second table is the Ballet's test, basically shows us whether the sample that was used was adequate. So if the value here is greater than 0.6, then it means that the sample was adequate. So in our case it was 0.914, which is of course greater than 0.6, so it means the sample was adequate, which was also confirmed by the significance here. If the significance is less than 0.5, then it means the sample was adequate. So in our case it's 0.000, that means it was adequate. So the other table is the anti-image table. So this table is just to show the covariance of the various variables. So it's these variables and the other variables up. So in our case we had three important factors that emerged. So these are the factors that have an eigenvalue greater than 1. So there are three factors, and these three factors explain up to 55.336% of the total variance of the data. So it can be seen from this scree plot is that one factor was the one that was most important, so it's the factor up here, and then this is just to show you which factors contain what variable. So the first factor had this variable, so the first factor had these variables as indicated here. So the second factor had these variables, and the third factor had 5 variables ranging from here to there. So this data can be summarized into 3 factors, and the 3 factors contain these sets of variables. So that is the first set, the second set, and the third set. So I believe right now you can comfortably conduct factor analysis. Thank you for listening.